Hi, welcome back to CMG-MathSpace. This is episode 3 or part 3 of our AKI-OLA core math series. And the topic is on the types of sets. We have looked at the introduction and then we have looked at the set notation. And this is part 3, that is the types of sets. So we have different types of sets, 7 of them at least. So without further ado, let's quickly look at the types of sets. Now, sets may be classified according to the number of elements in them, right? So we get to know the type of a set depending on the number of what element or the types of elements or members in them, right? So the first one is what? Finite sets. Finite. When it says something is finite, that means there is an end to that, or you can see the end of it. That is English. Now, in terms of mathematics, what is a finite set? It's a set whose last member, not number, the last member can be found, right? It's a last member can be found. So example here, we have a set A with the members 1, 2, 3, 4, 5. So it means that we can see 5. And after 5, there's no number there, no ellipses, no dot, 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 dot. So it's as simple as that. It's the simplest type of what set that we have. You have to understand this. So there's no member after 5. And that would have been denoted with what? Dot, 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 or the ellipses. So once there's nothing there, but the 5 is there, right, is what? A finite set. So we will understand it better when we look at the opposite of what? The finite set. That is what's called infinite. Infinite. That's 2. So example in Q, we have 1, 2, 3, 4, 5, 6. After 6, we can see that there's ellipses or there's dot, dot, dot there, which means a number is supposed to be there, or members are supposed to be there, but we can't find them there. It doesn't mean they are not there, right? So we see the ellipses there, so it means that it's infinite. It means that you can go on and on, on and on, on and on until you get tired. You getting tired doesn't mean there's no more number there or a member there. So that is what it means, right? So the 3 dots means the set continues indefinitely or has no end. Note, the object of an infinite set cannot be counted as it continues indefinitely. You understand? Now let's move to null sets or empty sets. Either of them is correct. Now, this is a set which has no member. It has no member or element, right, in them. And a null set is denoted, right, with this symbol, like an O or 0 with a cross through, or the empty curly brackets. There's nothing, no member in it. So this is how it is denoted. Note once again that the set, for example, A, right, is equal to has 0 in it, 0 figure in it. It's not an empty set, since 0 is a member of set A. You understand? So if you should give an example like A with a 0 in it, 0 is not an empty figure or let's say a null figure. It's actually a figure. We will look at the numbers or real numbers later. So if you see a set with a 0 figure in it, or any member at all, a letter or symbol or anything at all in it, that is not a null set. But when it is empty, then that is an null set. So that is what we are talking about. So though like the number 0, it may seem trivial, right? The 0 may seem trivial. The empty set is quite important in mathematics, right? So one may be asking, why, if it has no importance, if there's no figure or a member in it, why do we still need it? Don't worry, we will need them. It's very important in mathematics, right? So let's move on to unit set, a unit set that is 4. And this is a set which has only one member. Only one member. For example, set P having 5 in it, or Q having 2. It's a unit set. Unit, right? So understand English. If you don't understand English, that will be the problem. That's the problem that we have when it comes to mathematics. So can we conclude that people who have difficulty with mathematics means they don't understand English? I didn't see anything. You will have to find out maybe at AKI-OLA channel. We will mention that link in that you understand English, common English mistakes to boost your confidence. Right. So P5, one figure, one member in it. Q has 2, only one member in it. So it's a unit. So also example A, or maybe set A, having 0 in it is still a unit set, since 0 is the only member. You understand? Now let's move on to universal set. Right, it is a set of all the objects under discussion, the set of all numbers or objects under discussion. I don't know, I don't want to be too specific with the numbers or that, so we are going to stick to the members. Members or elements. Right, so it is denoted by the symbol U. It looks like a slanted U, or the S symbol in Tree alphabet. The S symbol. Sometimes drawing or trying to write this can be difficult. It doesn't matter. The important thing is that it's understood on the paper. Now, when a particular set is defined, we consider it as a set of a larger set, right? As a set of a larger set, which is referred to as universal sets. So, in example or in examination, you may be given I, list the set of what? Even numbers less than 10. Another set B, list a set of numbers or odd numbers less than 10. That's another set. Then maybe C, list all prime numbers less than 10. So all these sets are different sets. But if you should add them together in one particular set, you can have all of them as natural numbers or maybe integers. So the integer here is the universal set because it has all the members joined, or I mean the resultant members in all the individual sets. So that is what it's as simple as that. Get this. I'm taking my time to go through this thoroughly. Right. So for example, if the set of a triangle or triangles under discussion, right, for example, if the set of triangles is under discussion, then the universal set is taken to be the set of all polygons, right? So when it comes to shapes, we have given you example, right? So the universal set is represented by a rectangle when drawing a Venn diagram. We'll talk about this later. It's very, very important. Now let's go to a bit interesting or maybe a confusing one. Let's look at them, the last two. We have one called equivalent sets. So the equivalent sets is said, right, when two sets are said to be equivalent, if they have the same number of members. They have the same number of members. For example, if A, right, has 2, 3, 5, three members, right, and B also has 3 members, but this time different figures. We have 11, 12, 13, right, 11, 12, 13. Then A is said to be equivalent to B, right? Since they both have 3 members. So the important here, or the thing to note, is not on the particular number, but what we are talking about, the number of members. So set A has 3 members, set B has 3 members, right? So that is all. Don't think outside the box. That is as simple as that, because if you think outside the box, that's where we will move to the second type called